Alrighty, you guys. So the last thing we're going to do today is we are going to prove that the sine of 2x minus the cosine of x is equal to 0 on the interval from 0 to 2 pi. So because we have this interval right here, the best way to do this would be to integrate, because that's what intervals tells us. So we're going to integrate the sine of 2x minus the cosine of x from 0 to 2 pi. Um, so, um, let's do that. So many of you, though, might be asking, wait, is 0 my upper integral or my lower integral? And that's a honestly phenomenal question. My answer, though, is, well, think about it. Does it necessarily matter? And the answer is, in this case, no. But technically speaking, 0 would be your lower integral, while 2 pi would be or your lower bound, while 2 pi would be your upper bound, because your lower bound is where you start. So 0 to 2 pi. So what we can do here is we can separate that, the integration through one rule, and that then gives us, so the antiderivative, we want to find that. What we end up really getting, though, with the antiderivative before we even do this, because technically speaking, like I said, we can separate it out from 0 to 2 pi of sine of 2x minus 0 to 2 pi of cosine of x. So what this ends up getting when we calculate the antiderivative is we end up getting the sine of x minus 1 and then the second guy right here. Okay, ready? Maybe ready. I'll do them in different colors. All right. So I'll highlight this one in red. This one will highlight in yellow. And now ready, I'll even write them. So we end up getting the sine of x minus 1, sine of x plus c, which I don't know. I need to calm down. Ooh, this is a mess, you guys. I apologize. So let's take a deep breath. Okay, now that I'm calm, hopefully you are too. Like I said, we separated both of these right here. Separated this guy and this guy. So now let's calculate their respective integrals. So you end up getting the negative cosine of 2x over 2 when you calculate the antiderivative for the first half, minus the sine of x is the antiderivative cosine of x. So then last but not least, you're going to calculate the integral from 0 to 2 pi. And when you end up calculating that, you end up getting 0. So if we really want to look at it, it would be the, but this would be 0. And this is common sense in my mind if you think about it, because technically speaking, so the cosine, 2 times 0 is 0, the cosine here would be 1/2, or negative 1/2 minus the sine of 2 pi. So this actually ends up being 1, 1 minus 0. So this ends up being 1 when you plug in 0, and then minus, and then plug into pi. When you plug into pi here, you get 4 pi, negative cosine of 4 pi, 0, and 2, 0, and then sine of, no, be 1, my bad, be 1, and then the sine of 2 pi. It's also 0, so it ends up being 1 minus 1, which then ends up being 0. So this actually does check out. Again, and I'll show you that. That's how I got it. I know I just verbalized it. I'll still show it to you anyway. So again, when you plug in, so you have negative cosine of 2 times 0 all over 2 minus the sine of 0, and then this whole thing is subtracted by the same exact thing of 2 pi. So now this, like I said, this ends up getting 1. So this ends up being 1. Because technically 0. And then even if I were to erase this with here and put 2 pi, 0 and 2 pi are the same thing on the unit circle. So that's the reason why it would also be 0, which would then be 2. 1 minus 1, which is equal to 0. So like I said, it checks out. So it's, again, really just calculating the integration or the antiderivatives and then solving. That's the nice thing about 0 and 2 pi. Anything, or a lot of times you do end up getting 0 and 0 answer. So hopefully that makes sense. Let me know if you need anything.